Surface waters play an essential role as part of the ecosystem in the landscapes of Central Europe. Our rivers and lakes are nonetheless exposed to numerous pressures by pollutants or nutrients. The aim of the Water Framework Directive of the European Union is to identify these pressures and their sources and to achieve a good ecological status in all water bodies. The water managers are faced with enormous challenges for each river catchment under their care. They have to perform an inventory of the pressures in the catchment to determine the spatial extent of their sources and to take appropriate actions to reduce pollution. These pollutions can be, for instance, measured on the very site they originate from, as shown here in a meadow in the German catchment of the Erft. Staff of the Erftverband download recorded data and regularly collect water samples in order to determine the diffuse input from surface runoff and saltwater influx. In Luxembourg too, the question of the scale of agricultural pollution to surface waters is very actual. Specialists working at the research center Tudor calculate these emissions using a combination of monitoring techniques at the catchment's outlet. Automatic and passive samplers, as well as continuous measurements using sensors, allow a complete survey of the pesticide input from farmed areas. This data will be aggregated in the research center and combined with chemical analyses to determine the scale of pollution and to interpret the emission situation. This data is also the basis of a complex modeling of the catchment. Models such as the soil and water assessment tool SWOT used here simulate river discharge in a catchment and reproduce the dynamic of sediments and dissolved substances. A sound monitoring concept is essential for the validation of such models. Many substances are not only transported dissolved in water, but also attached onto fine sediment. In this way, they can accumulate on the riverbed over a longer period of time and find their way into the food web. Thus, mapping the sediment budgets and analyzing its composition is an important precondition to understand pollutant fate. Indeed, the properties of the sediments have a considerable influence on the ease with which pollutants get attached to them and on how mobile they are in the rivers. Sediment properties control the accumulation of pollutants on the riverbed and give information concerning sediment mobility. Exact measurements of their grain size, as shown here, performed in the laboratory of the Erftverband, is a decisive factor to model correctly their behavior. Water quality models such as the DWA model of the Erftverband continuously simulate the pollution of a river system. It is thus possible to predict the effect of a sewer overflows or another input on the entire river stretch. Nonetheless, such water quality models must be calibrated first. To that effect, an extensive database is necessary concerning the main parameters such as nutrients input. The Erftverband collects the data using online measurement stations working around the clock at a 1-minute interval. In order to use water quality models, the hydraulic characteristics of a river body must also be thoroughly known over the entire catchment. Here, the discharge is determined from a tracer test. Such a test consists of injecting a known mass of an innocuous dye in the river and measuring its concentration over time downriver. The staff of the Erftverband is once again in the field. Its aim, a soil retention filter. Contaminated sewage water that bypasses the wastewater treatment plant during rainstorms flows through the reeds growing in the filter and is in this way cleaned biologically before being released into a river. The decision as to which action must be taken to prevent river pollution depends on the major pollution sources. The models and accompanying monitoring help to evaluate the effectiveness of the different actions taken and allow to find their optimal combination with which to improve the water quality. The M3 project applies a variety of monitoring techniques and models in order to test in advance the effectiveness of different water protection management options. In this way, actions can be planned and implemented in the most optimal fashion. The experience gained will be circulated among water management experts and finds practical applications, thus enabling to reach the aim of a good ecological status in all water bodies.